Okay, you guys, chapter 6, the second half of chapter 6 is still talking about rational expressions. Main thing today for 6.4 is rational equations, and I mean that we will be solving things. So our answer should be x equals something. Okay, so that's the goal. Solving rational equations, so fractions. So main thing is this, and so I'm going to take a second, and this is what I would write down for sure for notes, is these steps. So the first thing you need to do, it says 1, list any numbers that will make a denominator 0. These are what we called the restrictions. Okay, restrictions meaning we can't have an answer that gives us a 0 on the bottom. So we want to find that before we even get started solving. Okay. The second thing, after you do that, it says find a common denominator for all fractions, for all rational terms. So this means make the bottoms the same. Okay. Okay. Once you have the bottoms the same, you don't have to worry about the bottoms anymore because you took care of them in the restrictions. Now focus only on the top and solve the top. Okay. All the way across, solve the top. After you get an answer that says x equals, you want to make sure that none of your answers do not equal your restrictions. Okay? And there's a word for that. It's called an extraneous, and I'll write that down. Extraneous, I believe. That might be wrong spelling, but extraneous solution. Okay? That means that it's an answer, but it's also a restriction, so it doesn't really work. Okay? So here's the first example. Example 1 says 2x minus 7 over 4x plus x plus 5 over x equals 8. So the first thing we need to do is we need to check the bottoms for restrictions. So I'm going to look at each bottom, and you're like, okay, 4x and x. So 4x can't equal 0, and x can't equal 0. And then you're like, Miss Bustle, that 8 doesn't have a bottom. Well, we're going to give it a bottom of 1. Okay, and in both of these situations, we get x can't be 0. So that would be our only domain restriction and our only answer we can't have. That's step 1. Step 2 now says get your bottoms the same. So this is 4 times x, this is x, and this is 1. So I'm going to have to make them all have a 4 and an x in it. So I'm going to give this one a 4 and an x on top and on bottom, and this one needs a 4. So then I get 2x minus 7 over 4x plus 4 times x plus 5 over 4x equals 8 times 4x over 4x. Do we see that? Okay, all of my bottoms are the same. Now that my bottoms are the same, I'm just going to focus on the top. And I'm going to solve that using my algebra skills, okay? So I get 2x minus 7 plus 4x plus 20 equals 32x, okay? On the side, I'm going to combine my x's. 2x and 4x is 6x. Negative 7 plus 20 is 13. Wow, ignore that. 6x plus 13 equals 32x. Okay, and then a minus 6x, and I get 13 equals, I don't know why, 26x. Divide by 26, divide by 26. Reduce that fraction, I get x equals 1/2. That's my answer. And I know that's a good answer because it's not the same as my restriction, okay? I don't know what. Whoa! Okay, Caution, okay? Keep this in mind. When solving a rational equation, be sure to list any restrictions as your first step. So basically, this is just reminding, make sure you know your restrictions before you start solving, so you know what your answer cannot be before you start solving and you get the answer that's a restriction, okay? Next one, example 2, x plus 3, x minus 3, this x squared minus 9. I need to factor this, and this factors into x plus 3, x minus 3. You can do box method, you can recognize this difference of squares. But my bottoms, I have x plus 3 can't equal 0, and x minus 3 can't equal 0. When I solve, I know x can't equal negative 3, and x can't equal positive 3. So those are my restrictions. Once I've done my restrictions, I'm going to make all the bottoms the same. So this first one needs an x minus 3. The second one needs the x plus 3. And then the last one has both of them already. So we get 8 times x minus 3 minus 6 times x plus 3 equals 2. And my bottoms are going to be all x plus 3, x minus 3. Okay, so with that situation, once my bottoms are the same, I can focus on the tops. And I get 8x minus 24. I have to distribute this negative through, so I get minus 6x minus 18 equals 2. And now I'm just solving. So I combine, I get 2x, because 8x minus 6x, and negative 24 and negative 18 ends up being negative 42 equals 2. Then I'm going to add the 42, and I get 2x equals 44, and I get x equals 22. And that's a good answer because it's not one of my restrictions, okay? Then the last example, you might see this wording. I don't know if you'll see it on the homework, but maybe on the review or the test. But it says, let f of a equal this, or y equal a minus 5 over a, right? F of a, f of x. Find all values for which y equals 4. So it's just technicality, it's just vocab. All this means, instead of saying y equals, it says have a minus 5a equal 4, and then solve. So we have a over 1 minus 5 over a equals 4 over 1. My restrictions would come from here, so a can't be 0, and then we're going to make all of them look the same. This needs an a, and this needs an a. So I get a squared over a minus 5 over a equals 4a over a. Okay, bottoms are the same, so I'm going to solve, and I get a squared minus 5 equals 4a. Okay, if you ever have a top where you have a squared or a cubed or anything, a to any power, you're going to need to factor. Okay, so I'm going to move everything to one side. Okay, and it factors, and you can do whatever steps, you can recognize it however you know how to factor, that's fine. But this factors into a minus 5, a plus 1, and you get a equals 5 because you set that equals 0, and a equals negative 1. And both those answers work because they're not the restriction that you had above. Okay, I know that's pretty quick and 3 really basic examples, but your homework's only 10 problems. You've got to show work. Make sure you follow those steps. Check your restrictions. Get a common denominator. Solve the tops. And then just make sure that your top, any of your answers are not your restrictions.